Three schools each sent 4 students to a competition. The scores earned by 9 of the students are given in the table below. The scores of the remaining 3 students are represented by X, Y, and Z. The total score for any school is determined by adding the scores of the 4 students competing from that school. What is the total score for school A? So school A, 12 for student A, second student's 8, third student's 10, fourth student's 6, so the total score would be 36. The total scores for school A and B are the same. What is the value of X? The score for student 4 at school B. All right, so if the total scores are the same, that means this 36 is equal to 17 plus 5 plus 7 plus X. And when you solve that, you will get X equal to 7. The total scores for schools A and C are the same. If the score for student 4 at school C is twice that of student 3 at school C, determine these 2 scores. All right. So again, 36 is going to be equivalent to 9 plus 15 plus Y plus Z. Now they're telling me this important fact that the score for student 4 at school C is twice that of student 3 at school C. So that basically means that this Z is equivalent to 2Y, like this. All right, so then plug that in there, and this will be 36 is 24 plus Y plus 2Y. This looks like 12 is 3Y, and therefore Y is equal to 4. And therefore Z would be equal to 8. And I think that is all they're asking for. When Esther and her older brother Paul run a race, Esther takes 5 steps every 2 seconds, and each of her steps is 0.4 meters long. Paul also takes 5 steps every 2 seconds, but each of his steps are 1.2. In meters, how far does Esther travel in 2 seconds? So Esther and Paul, 5 steps, I believe 5 steps also, and that's every 2 seconds. So every 2 seconds. And then the main difference, I guess, is the length of the step. So for 1 step for Esther, it's 0.4 meters, and 1 step for Paul is 1.2 meters. Okay, so in meters, how far does Esther travel in 2 seconds? Well, in 2 seconds, it's 5 steps, but each step is 0.4. So it would be 5 times 0.4, which is 2 meters. B, in meters per second, what is Paul's speed? Okay, well, the formula is speed is equal to distance over time. So speed in this case would be distance over time. The distance, I guess, we can go by 2 seconds. In 2 seconds, it's 5 steps, but each step is 1.2 meters. So that's the distance, and the time is 2 seconds. So this looks to me like 3, and the units would be meters per second. All right, part C. Let's move this up a bit. If they both start a race at the same time, what distance ahead will Paul be after 2 minutes? So 2 minutes, well, let's convert that to seconds, so 120 seconds. Now Esther, in 120 seconds, she will go 5 steps for every 2 seconds, so that's 60 intervals of 2 seconds, so 5 times 60. And then each of those steps is 0.4. So 120 meters is how far she travels in 120 seconds. Paul, same kind of story. Every 2 seconds it's 5 steps, but it's 60 intervals of 2 seconds because it's 120 seconds. So 60, and then his is 1.2. So this is 360. So after 2 minutes, Esther is at 120 meters and Paul is at 360 meters. So Paul is obviously 240 meters ahead of Esther, the difference between 360 and 120. If Esther begins a race 3 minutes before Paul, how much time does it take Paul to catch Esther? So Esther this time is 3 minutes, and let's convert that to seconds. So 180 seconds. And same story, this time it's 90 intervals of 2 seconds. So it's 90 times 5, and then each of those steps is 0.4. So that's 180 meters. Okay, and then let's see here. What's happening after that? How much time does it take Paul to catch Esther? Okay, so before Paul even starts the race, she's already run 180 meters. Okay. And then we got to figure out how much time it takes Paul to catch Esther. Okay. All right, so from that moment on, Esther, I guess her next phase would be you take her time and divide by 2, just like how we did up here, actually. Not much difference. And that would give me how many intervals of 2 seconds. And for each of those intervals, you multiply by the 5 steps. And for each of those steps, you multiply by 0.4. And that is basically how much she travels. Now, Paul is the same kind of thing. X over 2 times 5, but his steps are 1.2. And then since they catch one another, or I guess Paul catches Esther, this plus this, the total distance that Esther travels, has to equal Paul's distance. Okay, so that basically means that 180 plus x over 2 times 5 times 0.4 is equivalent to x over 2 times 5 times 1.2. All right, so that shouldn't be so bad. Let's see here. This becomes 180, and this, I believe, just becomes x, and then this becomes 3x. Okay, so that means 180 is equal to 2x, and therefore x is equal to 90. So 90 minutes is the answer. Is it minutes? Yeah, minutes is basically what we're working with. So 90 minutes. Or 90 seconds, sorry, 90 seconds. I got confused there because you're looking at intervals of 2 seconds. So 90 seconds. Let me write that in here. 90 seconds, just to be clear. All right. A median is a line segment drawn from a vertex of a triangle to the midpoint of the opposite side of the triangle. In the diagram, triangle ABC is right-angled and has side lengths 4 and 12. If AD is the median of ABC, what is the area of ACD? All right. So they told me that BC is 12, and these segments CD and DB are equal, so that means they're both 6. And then it told me AB is 4. All right, that sounds pretty straightforward enough. So the area of triangle ACD would be 1/2 base times height. The base ACD, the base is 6, and the height you can use 4. And therefore, that's just 12. So there you go. In rectangle EFGH, point S is on FH with SG perpendicular to FH. In triangle FGH, median FT is drawn as shown. FS is 18, SG is 24, and SH is 32. Determine the area of triangle FHT. All right, so a few steps here. Let's take it one step at a time, I guess. So the first step, I guess, would be, let's figure out FG. And then we can do that with Pythagoras, pretty straightforward. FG, let's see here. Squared would be, let's label this FS is 18, so that goes here. This is 18. And then SG is 24, that guy. So I guess we're just using 18 and 24. So 18 squared plus 24 squared. And then when you solve this, we get FG equal to 30. Okay, so let's put that in there. And then I guess the next part, we're trying to figure out triangle FHT, right? FHT. So we definitely would need to know the value for HT. Yeah. And did they give us anything else? SH they gave us. Oh, okay, that's 32. Okay. So, okay, then I can figure out HG, and then I can cut it in half because T is FT is the median. Okay, I got it. So let's just put in those little lines to show that those are equal. Okay, so using Pythagoras once more, it'll be hg squared plus 30 squared is equal to 32 plus 18 squared, the hypotenuse on that triangle. And I'll let you do this math. It comes out to 40 for hg. So if hg is 40, ht is 20. Correct? Because it's half. Because the t is the median and it cuts it in half. So therefore, the triangle FHT, that area, is 1/2 base times height. The base is 20. The height, you can use 30. And this is therefore 300. In quadrilateral KLMN, KM is perpendicular to LN at R. Medians KP and KQ are drawn in triangle KLM and KMN, respectively, as shown. LR is 6, RN is 12, KR is X, RM is 2X plus 2. What is the area? The area of KPMQ is 63. Determine the value of X. Sorry. So a lot more going on, but it shouldn't be too bad. Let's just summarize what they gave us. LR is 6, KR is X this time, RN is 12, and RM is 2X plus 2, and the area of KPMG is 63. All right, so a lot of the similar things that we did previously we're going to do this time. Now, what is KPMG? First of all, KPM and M, is it G or Q? Q. I don't know why I put a G there. Maybe because it looks like one. Okay, KPMQ, what is that? Well, it's some quadrilateral, but what is it defined as? I guess this is where we take into consideration that these are medians. So basically what it is, it's half of the area of triangle KLM, right? And because KP is the median, plus half of the area of triangle KMN, or KNM, whichever way you want to write it. Because KQ is a median. Yeah. Yeah, and they even tell you that KP and KQ are medians. So they cut those triangles in half, and then when you combine half of each of those triangles, you get KPMQ, this guy. All right, and they told me that is 63. Okay, now let's see if we can figure out the area of KLM, and then we'll figure out the area of KNM. KLM, 1/2 base times height. Yeah, 1/2 base. So the base I can use KM, and the height is LR. And then for this guy, KNM, the base I can use KM again. Wait, hold on. I need another half in there, because the area of this is 1/2 base times height. This half right here is this half. So I got to squeeze in another half in there. Yeah, don't make that mistake. And similarly, I got to squeeze in another half in here. So let's put in another half. You see what I mean? Little things like that can mess you up. Okay, so KNM, 1/2 base times height. Again, I can use KM, and then the height, I can use RN. Okay, so this will work. So here we go. This is 63. This is a quarter. 1/2 times a half. KM. Do we know what is KM? We don't. Okay, so that's the one thing we don't know. LR we do know. It's 6. And this is a quarter. Again, KM. And RN is 12. So therefore, this is going to be 63 is equal to, when you add this all up, 18 over 4 KM. And therefore, when you solve for KM, you will get 14. Okay, great. So we got 14 for KM, but I don't think that solves the question. They wanted us to figure out the value of X, all right? So what is X? Well, KM is KR plus RM, right? So since I have a numerical value for KM, I can put that in there. And then KR, they told me is X, and then RM, they told me is 2X plus 2, and there you go. Now we got an equation. So this will be 12 is equal to 3x, and therefore x would be equal to 4. And that solves the question. A bingo card has 25 different integers arranged into 5 rows and 5 columns labeled bingo, such that the middle integer is always O, B is between 1 and 15, I is between 16 and 30, N between 31 and 45, G between 46 60, and O between 61 and 75. What is the smallest possible sum of the numbers in the row bingo? Okay, bingo, there's a song, right? Okay, so the smallest possible value for B is 1, because it's between 1 and 15. Smallest possible value for I is 16, because it's between 16 and 30. Smallest possible value for N, it can contain the middle integer. So the smallest possible value for N, it can actually be 0. For G, smallest possible value 46, and for O, smallest possible value 61. And then when you add these guys up, you get the smallest possible sum, which is 124. Carrie's bingo card has a row and a diagonal, each with the same sum. What is the smallest possible such sum? Show that there is a bingo card with this sum and explain why there is no bingo card with a smaller such sum. All right, so we got to play around a little bit here. So let's see here. Let's draw this bingo and let's see what we can get. Bingo, and we got to make those. We got to make 5 and 5, right? So 5 rows, 5 columns. 1, 2, 3, 4, 5. Okay. So let's make a diagonal and let's make a row, because that's what they want. They want a row and a diagonal. So I'll just make the diagonal A, B, C, D. Well, this is always 0, so that's fixed. And then let's make a row W, X, Y, and Z. Okay, so they want a scenario where the row and the diagonal have equal sum. Okay, so the lowest sum is 124, right? So let's see what happens if we use 124. A plus B plus 0 plus C plus D is 124. Now we already know these numbers from up here are 1, 16, 46, and 61. Now, is there any way to make this row also equal 124? And I don't think so, because if we have W plus X plus 0 plus Y plus Z, these numbers have already been taken, these guys. So you can't use them again. So you can only use numbers that are obviously bigger, because these are the smallest numbers. So if you use numbers that are bigger, then the sum is going to be bigger. So for example, if you use 2, 17, 47, and 62, the sum will be 128. So as you can see, that's not going to work. You can't use 124 as your target sum. Okay, so that one's out. What else can you do? Can you use 125? Let's try 125. Let's see what happens. All right, A plus B plus 0 plus C plus D. If I use 125, then if I go up by 1, I would have to go down on the other by 1 also. Somehow I don't think that's going to work. Like, for example, if this is 116, just like before, but then we use 46, just like before, but then this time we use 62, right? We go up by 1. And you say, okay, that may work. And let's see what happens with WX, 0, Y, and Z. Here we can't use 1, we can use 2, 17, 47, but then this time we can go down to 61. But even if we did that, this sum ends up being 127. So you might say, well, wait a second, I think I can do this. I can figure this out. Let me just tweak the numbers a little bit. And for example, if I say make this 1, 16, 46, if I go up to 64, then that'll work. This will add up to 127. And this is 127. Great. I made it work. So you got it to work for 127, but you couldn't get it to work for 128. So now what you have to do is figure out the next part of the question, which is Explain why there's no bingo card with such a smaller sum. Is 127 the smallest sum, by the way? Well, 125 we showed cannot work. So 124 cannot work, 125 cannot work, 127, yep. So now we just have to see whether or not 126 is a possibility. And let's see. So again, same story, A, B, 0, C, and D, 126. Well, I can probably create a scenario where they add up to 126. 116, 47, and 62. That'll add up to 126. Now let's see if I can do the same thing with W, X, Y, and Z, those guys. And I think I can. If I go up one here, go up one here, but go down one here and go down one here to 61, that'll add up to 126. Yeah. Okay, so there you go. I made it work with 126. So 126 is the smallest sum, and through a process of trial and error, we showed that the only other two smaller sums, which are 124 and 125, cannot work if we're trying to make a diagonal equal to a row.